So we have negative 9 is 16 times a. But again, we want a, so what do? We divide. So we divide both sides by 16, as you can see. So we get negative 9 over 16 equals a. And then since we know a, we can plug it in and we're done. This is our function. And again, it doesn't hurt to check it, so let's check. Let me just move this up a bit, make it easier to see. All right, wait, hold on. There we go. Okay, so let me now just go to Desmos and graph that. Stop sharing it. Okay, so we got this. So let's do it. All right. So we have f of x equals negative 9 divided by 16. Okay, press the right arrow key. You gotta be careful because you don't want the rest of it in the denominator. So you have to get it up here. X minus 3 squared plus 5. And you can see here's our graph. You might have to may have to click and drag to move it around or zoom out. Like so. Then, okay, let's plot the points. So the 2 points we have are 3, 5. Well, you can see the point disappeared, so, but it's good to label it. The other point we had was negative 1, negative 4, as you can see. And we click label down there. This is on the graph. You can see that we have a parabola by the shape. Also, 3, 5 we have, that's the vertex. That's where the graph changes direction. So yeah, our answer is right. All right, cool. Now, do you have any questions about this? All right, let's do some other stuff. Okay, we'll do some more problems. Now these are going to be a little bit different. Okay, I thought something went wrong. So this one's a little bit different because now here I give you the graph. Okay, I give you the graph. So basically here we have this graph and we want to get an equation of this function, of the function whose graph is this. Well, how do we do that? Well, notice we do have a parabola, right? You know, just by looking at the shape. We also have the vertex, right? That's where it changes direction, right? You know, imagine walking along the graph. Up here, we change direction. We go back, we go up again. It's also where the graph hits its low point, or as in the previous example, where the graph hits its high point. So the vertex is this. Now here, there's 3 other points it passes through, but we really only need one of them to figure out what the equation is. But since this is the vertex, we have HK is 1, negative 4. So that tells us H is 1, K is negative 4, right? Plug it in. What's left? We got to figure out what A is. That's what we got to figure out. Now, what I did was I used the point 30, if I remember correctly. So that means when x is 3, y has to be 0. When x is 3, y has to be 0. Okay, So we have 0 equals a times 3 minus 1 squared minus 4, right? When x is 3, we have to get 0 back. Y has to be 0. So we plugged in 3. We can now manipulate. We get a times 2 squared minus 4, which of course is a times 4 minus 4, which is 4a minus 4. And we have to figure out what a is, so you just solve for it. So as you can see, what I'm doing is I'm adding 4 to both sides because we want to get a all alone. We divide both sides by 4, right? And we get 1 equals a, which is the same as saying a equals 1. So a is 1, and this is the graph. This is the equation, excuse me. I mean, I don't want to keep bouncing back and forth between Desmos, but you really could graph this and see if you get the same exact graph. All right. Okay, do you have any questions about that? Okay. So here's another example. Here we're going to solve a quadratic equation. Well, we're going to solve an equation. Now notice it looks like this is something I never taught because it's degree 3, right? However, right away you can see every term here has an x. Every term has an x. So we can factor out x at least. But let's factor out the GCF. Let's find it and factor it. So we have, remember the GCF looks like this, b times x to the n. Okay, so the smallest power of x is 1, as we can see. So m is 1. 6 and 9 and negative 6. Well, actually, no, just 6, I guess. No, I'm sorry, negative 6, I was right. You can list the factors of it, but the greatest common factor is 3. I mean, you would just see that. So b would be 3, and our GCF then would be 3 times x to the first, which is 3x. So we get 3 times x as our GCF. So we can factor it out. Remember, when you factor it out, you put it in front, but you have to divide to see what's left over. And when you divide into a sum or difference, you divide into each term, like here. So we get 3x. And so from here, we have 6 over 3 is 2, right? X cubed over x is x squared. 9x squared over 3x is 3x, as we know. 6x over 3x is just 2. So we have this. You know, when you divide coefficients. And what you also do is you subtract the exponents of the variable. So that's what we get. Okay, so now, since we're solving this, remember we want to factor 3x we have to factor this quadratic now. Remember, if I don't tell you what method to use, you can use any method you want. But if I tell you to use a certain method, you have to use that method. Okay, so, but here I'm just demonstrating how you can solve this by factoring. So we have to factor this now. Well, here we're going to have to use the AC method. Okay, so remember you have a times c, which is 2 times negative 2, which in this case is negative 4. So we need two numbers whose product is negative 4 and the sum is 3. So the product is negative 4 and the sum is 3. Okay, so what numbers do that? Well, hopefully it's not hard to see that 4 and negative 1 are going to pull that off. So, I mean, I know it's on the slide, but you should be able to get that anyway. So in particular, 3 is 4 plus negative 1. Right? Remember, what you do next is you replace 3 in 3x, the middle term, with 4 plus negative 1 times x. Like so. Okay? Then you distribute the x, right? Because you got to multiply it out. We get 2x squared plus 4 times x plus negative x, okay, minus 2. So this is what we get, as you can see. Again, we have to distribute that x. So we have 4 terms. Now we can group them, right? With the grouping, it's good to try the first 2 terms and the third and fourth term together. You know, it may not work, but it's worth a shot. Okay, good. Notice also, I say this in the next slide, the second and fourth term have opposite signs. One's positive, one's negative, right? So we know at least in the second group, we're going to have to factor out a negative at least. You know, it's something just to keep in mind. Okay.